Look up at the night sky, and you are looking at a universe constantly at work. Across billions of light years, galaxies are drifting apart, and massive stars are aggressively burning off energy, illuminating the darkness around them. All that intense activity comes with a strict physical limit, defined by the second law of thermodynamics. The cosmos is slowly burning through a finite supply of fuel, moving steadily toward a state of total disorder and exhaustion. If the universe had existed for an infinite amount of time, every star would have exhausted its fuel reserves an eternity ago. The entire system would have already reached its equilibrium end state, a dark, cold, and quiet finish. We know that hasn't happened. All you have to do is look at the active solar flares and ongoing fusion in our own sun to see that the engine is still running. Because the fuel isn't gone, the timeline of the universe has to be finite. To determine exactly how long that timeline has been running, astronomers track the current outward movement of galaxies and reverse the process. Run the tape backward, and everything currently expanding is forced back together. The distances between galaxies shrink, the temperature spikes, and the entire volume of reality condenses into an increasingly dense, boiling state. Trace that trajectory back exactly 13.7 billion years, and all matter, space, and time converge into a single microscopic point. This convergence marks the edge of our physical understanding, leaving us with the mystery of what happens next. That microscopic point is known as a gravitational singularity. At this exact moment, 13.7 billion years ago, absolutely everything, all space, time, energy, and matter, was squeezed into one infinitely hot, infinitely dense state. It's natural to wonder what existed prior. But because the properties of time and space themselves began at this specific singularity, the phrase "before the Big Bang" is mathematically meaningless. It's exactly like asking, what is north of the North Pole? This origin point is universally known as the Big Bang, though the name is a misnomer. For starters, there was nothing big about it. At its inception, the entire universe was incomparably smaller than the size of a single proton. It was also not a bang. We often picture a bomb erupting and throwing shrapnel into an enormous empty room, but that completely misrepresents the mechanics of the early cosmos. Instead of an explosion, it was a sudden stretching. Space itself began inflating, everywhere, all at once. Think of raisins in a loaf of bread. As the dough rises and expands, the raisins move further apart. There is no central point of the explosion. Every part of the bread is simply stretching away from every other part. Because the stretching happens uniformly in every direction, an observer on any galaxy would see everything else moving away from them. You could stand on a galaxy billions of light years away, look out, and it would appear as if you were the exact center of the expansion. This uniformity is called the cosmological principle. It assumes that on a large enough scale, matter is evenly distributed across the cosmos, a fact confirmed by deep field observations from the Hubble Space Telescope. This sprawling expansion is governed by the general theory of relativity. Albert Einstein's framework provided the rules to explain how such a massive structure holds together while continually growing. Combine Einstein's physics with the cosmological principle, and a simultaneous, boundless stretching of space becomes the only mathematical model that fits the cosmos we observe. And this brings up one final paradox. The first law of thermodynamics states that energy cannot be created or destroyed. So how does an entire universe appear without violating the laws of physics? The answer is that the Big Bang Theory does not actually attempt to address the absolute creation of the universe. It is strictly a model of evolution. It charts how a pre-existing, unimaginably dense state transformed over 13.7 billion years. The absolute origin remains outside the remit of physics and is instead the concern of philosophy, which makes the label we use to describe this evolution highly ironic. The term Big Bang was originally coined as a derisive insult. During a 1949 radio broadcast, astronomer Fred Hoyle used the phrase to mock a concept he vehemently disagreed with. The insult backfired. The phrase stuck in the public consciousness and eventually became the undisputed title for our most successful cosmic model. We are not looking at a finished creation story. We are witnessing an ongoing, dynamic evolution of space, one still birthing our reality today.